Okay, so today is the 15th of February. I'm not sure, I guess this is probably not lecture number 4. So we're going to continue on a little bit with presentations from students. I think we just have one. TJ, you did yours, didn't you? Yeah. So we just have one today, and I'll go through a couple of online ones, and then we'll move on with the lecture. So with that, it's all yours.
What I am going to present here is a grocery store where customers are going to enter the grocery store and then shop, and then it's going to be the payment type, whether they're going to choose card, cash, or check, and then the next process will be whether or not they choose plastic or paper, and then they'll leave the store. And I'll simulate it. And pretty much with this, it's simulating one line at the grocery store with like 150 customers coming through like a line a day.
So, click on it. So the grocery shop, that's their first process, right?
Mm-hmm.
So click on that, let's just see what that's. Okay, I think you're still running, that's why I wasn't seeing the
Oh.
cue. That's what.
There it goes.
Okay, so go back to the customer inference. You're bringing customers in and random exponential about a minute. And then you go to the grocery shop. So using triangular 0.5 and 1.5.
Anyway, by chance.
So how does that work now? I'm not sure. Anyway, by chance, you have 3 possible paths.
Mm-hmm.
So how do they pass through? 60 to the first, 30 to the second?
Yeah, and then the faults would be
Balance to the last one?
Mhm.
Okay. I'm not sure I've ever done multiple by chance. Actually, we'll probably may do that next time. The next model you do is n-way by variable. So you'll look ahead at a queue or something and make a decision based on that. That's pretty useful. Okay. And so each one of those are using the same resource or different resources for each?
same resource.
Same resource. And then another decision point, paper or plastic.
Mm-hmm.
Okay,
Yeah.
Yeah, that's good. That's what I was really looking for. This is just sort of a, sort of a fairly straightforward simulation that at least shows that, you got grasp of the software. So. Okay, I was just going to pull up a couple of additional ones that students that are taking this online had sent in. Let's save that. What was interesting for you folks that are online, especially as we get more into this, Mohammed sent a Word document which sort of outlined what his thought process was. I think any of you that are online, I'd ask you to do that. Again, nothing formal, could be bullet items, just so I can sort of understand what you were thinking about. I can most times derive that from your simulation, but this made it a little easier. So if you could just include something, again, nothing real formal, bullet points or like a little narrative like he had here is fine. But that was helpful. And then in his model, this was a machining operation, which again is a good application for Arena. And he had so he had how many processes here? If I can get this whole thing on the screen. There we go. So first was bringing the parts in, much like everybody's done, using a random distribution. He's shutting it off at 1,000 arrivals, which is fine. That's a good way to do that. And then the first operation was to mill the part using a milling machine resource, seize, delay, release on the action on that resource, and priority just left as medium. This is something else that in the next model that you do, which we'll talk about in a bit, I would ask that you mess around with priority a little bit. But a couple other things you need to do sort of to facilitate you being able to see that, and I'll talk about that in a second. And then the triangular, again, we should probably, or I'd like to see us maybe do a couple iterations of our next assignment and vary our distribution a little bit to see what the impact is on the system. That's one of the benefits here, but that's good. Mill the part, again, it's got a queue, seize, delay, release. Comes in and inspects the part, two-way by chance, 85% are good, 15% bad. The bad ones get reworked, go to a rework station. Again, using a different resource this time than the milling machine, which is good. And a slower processing time. Here he was processing parts at 0.51 and 1.5. Down here on the rework loop, it was 3.5 and 7.5. And that's probably a good estimation for reality. It's going to take you longer typically to rework a part than it would to make it. So the break point here would be to take this decision point and play with this number a little bit. Maybe it runs fine at 85. If it drops to 80, what happens to the model? Do you tend to lock things up, or is it able to accommodate that? So this was good. What's that?
Rework was only in minutes. The mill was in hours. So he's got the rework.
Oh, I didn't see that. Yeah, you're right. No, somebody else did that too. I didn't pick it up on this one though. Yeah, okay, so that was in minutes, and the rework was in hours. No, that was in minutes. Yeah. Somebody else did that. And I noticed, I was running their model. I'm going, man, that seems funny. And it was, they were coming in once every hour and then being processed in like 1 minute. So they never built a queue, no matter what, you know. So, but yeah, these are both in minutes, so that's good. And that's a reasonable thing. And what you're looking for here, in this case, since he's got separate resources, you're not going to starve the resource, but you may bog the system down, where you just keep building queues here and you never get rid of them, if that defect number gets too large. So, and this thing seems to run pretty good. You start to build a queue here, but you deplete it pretty fast. Same thing up here. So, we'll just let this run for a couple minutes here and then look at the report. Did he set this to 1,000, I think? Crank that up a little bit. So if we look at that's only the first page. There we go. So you can see some of the entities and the times and whatnot have been correlated, which is good. It means that it's statistically valid. Okay, if it's not, then you want to go back and look at that again. The half width being so small, that's a pretty good sign too. That's close to being correlated. So again, what do we see there? Well, you've got a value added time, you've got an average of 0.03, a minimum of 0.208, and a max of 0.28, let's say. So that's a pretty good multiple there. You've got a pretty good range that you're seeing in that, but still within the ability of the system to manage. Again, wait time, which would be in your queues, similar kind of thing. Of course, the minimum, if there's nothing in your way in that resource, if it's not been seized, then your wait time would be 0. So that would be the minimum, and the max would be 1.4. So these seem to be within reason. Sometimes you'll see numbers that are, 100 times different, and that's sort of indicative that there might be a problem. a problem in that, not a problem with your model, but a problem in that your statistical assumptions may be driving it into a crash or into a place where it can't manage perturbations or changes in the system. And again, the queues, looking at the queues, and here you're correlated on the rework. Not enough parts had run through that was the deal there. And again, looking at the average and looking at your maximum. On your mill part queue, that's interesting. You've got a maximum of 43 waiting and an average of 13. So that would be something you might want to look at and tweak that distribution a little bit. Maybe modify it so instead of I think his midpoint was 1, right? It's 0.51, 1.5. Change the midpoint to 1.2. Skew it a little bit and see if that drives this into a sort of a death spiral, if you will, because that's a pretty big difference between the queues. And as we do more of this is really the kind of stuff I want you to sort of get used to looking at, to say, well, what if I change this? What if I change that? Because again, the intent of this, I guess the intent is, yeah, to have ultimately have a model that runs consistently, but the real intent is to break it, is to find out what changes in your distributions or in your resource allocations are going to cause problems that will cause the system to crash or not to execute properly. And again, looking through some of these times, some of these are duplicates of what we looked at. So this is nothing really out of line here. No frequency. We didn't have any processes picked off. Queues. Sometimes this is helpful. You've got, again, the number waiting in the queue, and this I believe is as it stopped when the system was done running. That's what was in place. Resources. Again, in this case, he had 2 resources, so there was no resource depletion really. But again, something else to look at. We didn't specify anything. I don't think he had any transfers, nor any tanks. So that was good. A good something to build on. Good, little rework loop here. Sort of seemed like realistic numbers between the 2 resources. So that's a good thing. Okay, so that was. I won't save the changes to that. Who else did I have? Okay, this was. Yeah, we didn't go through this one last time, did we? I don't remember seeing this. No. Okay, so this looks like it's a real process. Maybe this is something where this person works or whatever. But bundles enter a load former. Load former stacks the bundles for shipment. Units get strapped or wrapped. Some get strapped, some get wrapped, apparently. So that's the way they go. Not really sure what the bundles are. But if we look at it again, 8 minutes, 1,000 arrivals max. That shuts the system down. Our first process, again, sees delay release. That's good. No priority in this case. Using a resource called load former. Triangular distribution, 0.51 and 1.5. And then a side module, which is going to send 25% to the wrapper and 75% to the strapper. So this should run without any issues, really. If there's only one process, typically in a simulation, as long as the distribution you picked here is faster than the one you picked here, which it most likely will be, even though this one's random, typically things will run without any issues. So in this case, not even building a queue. There we got one part in the queue. You can see the numbers flashing. Every once in a while you get one in there. Most likely this will correlate on everything too, because again you only have the 2 distributions and the values chosen are such that it should pretty much run without any conflict. Get to 1,000. There we go. So get a number out to 1,000. No, we didn't correlate. That's interesting. I would have thought we would have. So again, the values are a little closer here. The average, min and the max, not that far apart. A little bit more on the wait time, although you really only had one in the queue at any point in time as far as I could see. So time in the queue, number waiting, maximum was 2, so at one point there was 2 parts in there. That was the maximum wait time then. And that sort of makes sense if you think about it, right? If your maximum value, if your processing time is about a minute, and worst case you had 2 in the queue, your maximum value for your wait time would be approximately twice your processing time, plus a little bit, which is what you have there. So that makes sense. It's always sort of a good idea, not just with this, but sort of with any kind of simulation you're doing, that you look and sort of do a sanity check if you see a number that's way out of whack, or even just check, sort of like I did to say, yeah, these numbers sort of jive, they sort of make sense. And the fact that this number was 2, if we watched that thing run, we never really saw the queue build. If this was 300, you might question what's going on with the system. And very small waiting time again. Okay, so that's good. I don't know if anybody else didn't present. I don't know. He didn't. I can tell because it doesn't build any files. It's never been opened. Okay, this we got a little animation on. We got a person over here. Not sure what they're going to do. Yeah, that's the other thing. I mentioned that somebody that came in early, that this version of Arena, they took some things out that I thought were pretty useful. And one of them I had mentioned was the ability to use a schedule and to easily manipulate that schedule. You can still use a schedule, but you used to be able to do it. You'd have a bar graph that would be broken up in your units. So if you had units of hours or minutes or whatever, you could change your resources and change your arrival times with this bar graph, and it was so easy to use. And I tried to get that, I tried to do that, preparing for the lecture today, and I couldn't get it to do it. And come to find out, they took that out of the system. So you can still use a schedule, but you need to fill it out like a spreadsheet. So you'd fill out your resource levels per unit of time in little boxes, sort of like a spreadsheet thing. I don't know that you can download something from Excel. That was the other thing I thought of. I looked at it and wasn't able to figure out how to do it yet, but I thought that was a big loss with the system. I'm not really sure why they did that. They did add a bunch of stuff. They added a bunch of this packaging stuff, which again gives some visuals, but doesn't really give you any additional information, at least as far as I can tell, over the basic process or advanced process modules. So I'm not sure what the benefit there was, but anyway. So this looks like I would suspect the person's buying a phone. Customer walks in, wishes to switch carriers, probably to Verizon. They just went with unlimited data again, which is good. If credit check comes out good, they go this way, they buy the phone, monthly bill. If it's not so good, they have to pay a deposit. Customer decides to pay, yes, then they buy the phone, no, then they don't. So that's you can go through this quick. So this one's only running to 50 arrivals, 1 minute random, first process. So this is not seize delay release, this is delay. So I'm not quite sure how this is going to behave. I'm not sure this is going to run because this was the one I think that had the hours in it. So the parts are arriving by minutes but are being processed by hours, which could very well be reality in the phone store, but I'm not sure it'll run with the limitations. On our system, we can have 150 entities in the system at any point in time. So that includes queues and processing times. So if you get into a situation where your processing times shoot way up and your arrival times, parts keep coming in, you'll pretty quickly get 150 in the system, and then it'll not work anymore. You got basically shut down. You get an error. So anyway, the decide module, 80% of the people had good credit. The ones that didn't came down this way. Again, they got processed to pay for another hour. They pay a $300 deposit. And 10% decided to pay. 90% didn't. So these are just dispose modules. So there's no, all these are basically just sort of exits out of the system. The only thing they can really do is you can either decide to record the entities or not. And this one again was 80% true. So let's see what happens when we run it. Yeah, so this, let's look at the statistics. I'm not sure exactly what it's going to tell us. So just doing the delay on the resource, you're not really seizing it, so entities can still continue to come in. So I'm not sure if these values are really, strictly speaking, valid. Let's just change that to, let's just change this to seize, delay, release. I have to stop it first. Hold on. Okay, change this to seize, delay, release. The other thing, if you're just doing delay, you're not consuming a resource. Which you want to do. You definitely want to consume a resource. So I have a feeling when I run this, it's not gonna, it's gonna shut down pretty good. It did run, ran 50 people. That's good. I'm surprised. Well, that's right. You're not gonna get, that's a good point. That's one way to stop from getting over 150. Don't let 150 in. You say, no, 50, that's it, done. Yeah, so that would happen if we set that to 1,000 or something. That would happen that way. But interesting using the people. That's a good little, visual there, a graphic there. And if we do that, am I still running here? I guess I am. Yeah. So where you would do that, and that was one of the things I was going to talk about today, is you can set this picture. So he put a picture of a person in, which is good. Most of the pictures are pretty simple kind of things. They're like red balls and blue balls and green balls and bikes and stuff. But they're useful because, and I'll show you why in a model here in a second, but where they're very useful, and it doesn't really matter what they are, red ball, green ball is fine, whatever, is if I want to sort of get a good visualization of how many parts are going this way versus how many parts are going that way. Especially if I'm doing things where I'm looking at a variable. It's pretty easy if you're doing, by chance, you can sort of, intuitively sort of visualize that in your mind. But if you're doing things where you're looking ahead at a queue, for example, and you're sending parts to the queue that's the smallest, it's useful sometimes to change that entity when it comes out this way versus this way. So one way is green, the other way is red. So you can sort of see what's going on a little bit easier. So, but that's good. That would be the only change I would have made to this, would be to go to a seize, delay, release on the resource. So I consume that resource and I can get a better picture of what's really happening. And if we did change this, let's just do that. We'll change this to 100. Change this to 500. And now if we run it, you can see people are getting pretty stopped up there. And this is the error that you get. If you see this error, and it's pretty self-explanatory, but you've got a maximum of 150 entities and you've exceeded that. So that's a good indicator that something's awry. And I'll leave those. Let me just call this one up. I don't know if I showed you this one or not. What was I trying to do here? Okay, so what I was doing here, again, this is just a sort of a demonstration of using the priorities and assigning different pictures. So again, we create the part, minute coming in. I left it as infinite variable arrivals. And then I have a simple decide 50-50. One goes one way, the other goes the other way. And then I'm using the assign module, which is something new. And what I'm doing on the upper leg is assigning it an entity type of red ball. So I can change lots of different things here. And I'm assigning an entity picture of a picture of a red ball. And then I'm assigning it a priority of 1. The lower leg, I've got, again, an entity type. I assign that yellow ball, and I give it a entity picture of a yellow ball. And then I come in and drill the part, again, seize, delay, release, with that distribution, and then I send the parts on their way. So let's just see what happens when we run that. So I don't know if you can see what's happening here on the screen, but since I put the red ball with a priority of 1, whenever that appears in the queue, it goes right to the head of the line. Okay, so that I can't think of a real great example right now, but if there's, well, I guess in a not so much in this application where you're drilling a part, but if you were in a emergency room setting of some sort, the red ball may signify, broken leg or critical emergency, and they want to go right to the head of the line. So this is a way to do that by assigning a priority to it. And the changing the picture just gives me a good visualization. If I didn't do that, I wouldn't be able to tell what's really happening with that cue. So this is a good way to visualize. Now I've got the run speed slowed way down, so I can see what's happening. And you can change things, like if I changed my decide part type and I made it, say I made it 10%, or made it 90%, so that 90% of the parts were going towards the red ball, that queue on drill part would build up, and I'd never be getting any of the bottom parts out, or the yellow ball parts out, right? Because 9 out of 10 would be red, and they go to the head of the line, so that just keeps pushing the yellow ones back. So that's the sort of the place you can get, in trouble with in terms of processing. But you can see, again, this is why you run things for a long time, is you see that queue for whatever reason is building. The statistical interactions of the statistical distributions that I'm using to bring parts in and to process them is such that it causes that queue to build. And then after a while, it should shrink, like you see there, and then build again. So it's a good visualization tool to be able to change my entity picture. And again, it doesn't really matter what it is. It'd be nice maybe if it was something more, more representative of a manufacturing operation, but yellow balls and red balls work. So that's what we got. Okay, we can stop that. So this is just, what I clicked on was that picture of that person there, and this is something you can use. I don't really know how, to be honest with you, how useful it is. Since we're using a student version, we're pretty limited with pictures. But what it allows you to do is you add these pictures in. In this case, when it's idle, the guy with the blue sweater shows up. When it's busy, the guy with the green sweater shows up. So again, it somewhat gives you an indication of the resource and whether it's being consumed. So there's some value to it, but somewhat limited. But that's what that picture is showing. So that's, again, using priorities, and you do that with the assign module, and a bunch of things can happen here. I can assign an attribute of a priority. I can assign an entity picture. I can assign a entity type. I can also assign values to variables. So things you can look at are variables. Things you can assign are variables, attributes, and entity types, entity pictures. And then there's other things you can do as well. I'm not sure what falls in the other category. I think that's just if you've picked a variable that you want to change. The other thing you can do is, so what I did here is I established a entity value, right? If I did an array, that's what this row popping up is. I can assign a value. I can also increment that value. So I can assign a value, so the first time through, and we'll do that in the next exercise, I can assign an attribute to a given entity, and if it comes through the line again, it'll get incremented. And I'll show you that here in a second. In fact, let me go to that now. That's probably a good time to jump to that one. Close this. What I did with this one. Same type of thing. This one's basically the same type of thing. Just it's a rework loop, which is similar to what one of the students did, where I'm drilling a hole, and all I did here was assign a different picture to it, so that when it's coming through this loop, I can see that it's a rework part, not an original. I'll just run that real quick. Sort of got to slow that down a bit. You can see when the red ones pop up, those are ones that are coming through the rework. There we go. So it comes up as a red ball and shows. So again, just gives you a visual. Is it a part that's entering the system, or is it one that has been reworked? We'll come back to the cheeseburger one. That's a good one. That's my favorite one. Okay, so this is a little bit more complicated. What's happening here is as always, we have the parts coming through. We're coming in through a create module. Lost my train of thought there. A create module, which again just brings the parts in at some given exponential or whatever, in this case exponential distribution. First process is a stamping operation. I've picked some different numbers here, and I intentionally have some conflicts. This can run up to 8 minutes, where the parts are coming in typically at a 6-minute interval. So you're going to wind up with some potential conflicts there. Drilling operation, again, this one's pretty fast the way it's set up. Again, different resources, drill press here. And you can also see that down here. If you've not sort of played around with the windows a little bit, you've got the ability to look at things in different ways. Down here in sort of a spreadsheet format, as well as up on the top in a graphical format. So then I drill the part and I inspect the part. Now what I did here, what we've done so far is we've just used the side modules. And in this case, we're just saying 50-50, and that can obviously be changed. But I also included a process here, and the reason I did that is because I wanted to capture that resource. If I was running a manufacturing operation, that inspect part doesn't come for free, right? There's a resource associated with it. I need to schedule that resource. I need to make sure that I'm inspecting it fast enough to keep up with the rest of the line. If I just put a decide module in there, I don't have that visibility, right? All I know is I'm inspecting it, Some percentage go one way, some percentage go the other. So if you want to capture that resource and capture the labor hours that are associated with it, and also make sure that you can do it fast enough to keep up with the system, you need to throw a process module in there, which is what I did. So I put a inspect part in there. It's got a resource of inspect. I've got one there, one unit of resource, again, seize, delay, release. Standard type. We're not going to get into submodels yet. We'll do that later. Priority, I'm just leaving it as medium, so everything is medium. I'm not looking at this as something I want to be, I see I've got that as hours. That's not good. I'll put that as minutes. So that allows me to capture that resource. If I look at my resources, I've got, again, 3 resources: my stamping press, my drill press, and my inspect. In this case, I've got everything based on a fixed capacity, which I can change and make it a schedule. A little bit harder to use with this version than the older one, but still can be used. So then what I'm doing a little bit different here than we've done in the past. Again, I inspect the whole, I send some percentage through a rework loop, and I send some out the door. What I do here is I don't want to keep running parts through the system, right? If I have a reject part, maybe I want to do it 2 or 3 times or 4 times or 1 time, whatever it is. And if I don't get it fixed on that first second pass through the system, I want to get rid of it, okay? So that's what I'm doing here. I've assigned a, again, I did my picture thing. I made it a red page. I forget what it was up here, but I changed it from what it was. And what I'm doing is assigning a variable. I want to see the number of tries that I make. So that's a global thing that I'm looking at. And you can see that if it comes through and it's not been through before, then it'll assign that variable to it. If it's been through before, it'll take the number of times or number of tries and add 1 to it. So in other words, increment it. So at the end of the day, I'll know how many reject parts I had to look at. That's a variable that I've assigned as a user. It's a user specified variable, and allows me to keep track of how many times did I have to rework a part. Now what I did in addition to that is I assigned an attribute. So again, the variable is a global simulation model characteristic, where the attribute is specific to an entity. So when the entity comes through, if it comes through that loop first time, it'll have an attribute called drill defect of 1. If it comes through again, it'll increment by 1. Okay, so first time through is 1, second time through obviously is 2, third time through is 3. What did I do here? Yeah, I renamed it. Why did I do that? Okay. I was clicking around a little too much there. Okay, so coming through this loop, I'm incrementing a variable, global thing, and I'm incrementing an attribute, entity-based thing. And then what I do is I look at, so here we did a decide module. Up to this point, we've done, most of the stuff we've done has been 2-way or n-way by condition, just a percentage. In this case, though, what I'm looking at is if, and it's just simple Boolean logic, if my attribute, called drill defect, is greater than 2, then I exit the system. Okay, so simple, straightforward stuff. Again, I can pick anything I want to look at here: entity type, expression, attribute, variables, whatever. In this case, I'm looking at the attribute. The attribute I'm looking at is the one called drill defect. I could have multiple attributes for a given entity. So it doesn't, you're not restricted to just having one. In this case, the one I'm looking at, again, is drill defect. If it's greater than, and then whatever value I plug in here, in this case 2, then this decide module is true, and the part leaves the system. If it doesn't, it goes back and gets reworked through the original system. Okay. So in this case, my rework loop is going back into the original manufacturing system. You don't always have to do it that way, and sometimes it makes sense not to. In fact, one of the models we looked at, they had a separate process module with a separate resource and a different time as well. So that sometimes is more closely aligned to what the actual physical system might be. And again, I've got a couple pictures up here, same sort of thing. looking at, look, again, just showing the state of the resource, basically, if it's idle or if it's busy. Same on this. That's the other thing which they've limited a little bit with this version is we only have a limited number of pictures. When I first opened up, I think they call it, what do they call it? Symbol Factory. I said, oh, that's good. They got some more symbols in there. Unfortunately, with the student edition, we only can use the first symbol out of each category. So, somewhat limited. So, why don't we take, before I run this, why don't we take a quick break? And, okay, so if we look at this, let's just go ahead and run it. I'm not sure where the numbers are right now, but let's just run it. So you can see that as you go through the loop, I guess the first picture was green page, and then I changed it to red page. And we should see some get rejected here in a minute, once we get a couple that have gone through a couple times. We only got one rejected so far, I guess. There we go, there's another one. So anytime you've got an entity that's gone through the loop more than twice, in other words, 3 times, it gets bumped into the reject part exit. So again, looking at some of the characteristics or the data that we get back, we've got our value added time for the blank. Again, we've got a couple operations there, right? Blank, and then what was the other one? Drill press, I guess? Yeah, drill press. So you get a value added time, your average, your min, and your max. And those look sort of in line. I guess you're going to get that level of variation based on the distribution that you picked. Wait time, again, sometimes this is a critical characteristic in a manufacturing operation. Typically it's not that huge. Sometimes the number of parts can be, simply because you have to have someplace to put them, but typically the wait time isn't as important as your average processing time. In other applications like fast food and health service, that maximum wait time can be critical. When we get into fast food, we'll do some of those exercises. Usage, user specified. So this was a variable that we set, number of tries, number of maximum was 10, min was 0, and 5.88 was my average. So that's the user specified variable that I set in this case that I wanted to keep track of. So again, pretty straightforward. The things I wanted to get across today was a couple things. One is that using the inspect or decide module as an inspect module is sort of how we use it. You're not consuming any resource time. So if you're running a manufacturing or simulating a manufacturing operation, or really any kind of operation that's got an inspection process to it, could be in fast food as well, I suppose. You're not consuming a resource, and so you're not taking into account the dollars that you're spending on that resource, and you're also not taking into account the time that you need to have that resource there. So you can run into a bottleneck if you don't look at that. You need to include a process module to do that. And then the other thing is, again, these assign modules and just some of the things that I can assign. I can change my picture to give me a better visual, better graphic on the nature of the process. And then I can assign and then increment both variables and attributes. Again, variables being global to the simulation, attributes being specific to an entity. So each entity may have a different attribute value associated with it. May have some entities that pass through the system will never even have that attribute because they didn't go through the rework station. So a little different there. And then again, looking at a decide module. I must still have this thing running. Just cancel that. Hold on a second here. So again, the other thing we're introducing today is using a decide module, and instead of doing it by chance, I'm doing it by condition. So I'm looking at the value of, in this case, an attribute, although I could do it with a variable as well, or number in a queue. There's a lot of things I can use, but in this case, just simply an attribute. So it looks at each entity as it comes through. It evaluates that attribute of the specific entity that's passing through the module. In this case, called drill defect, and it says that if that attribute has a value that's greater than, in this case, greater than, I can make this equals, less than, whatever. And I plug my value in there, in this case 2. I could make it whatever I want. It then will be true, and will, in this case, will exit the system. So that's, and each week that we do this, this is the kind of thing we're going to do. I'll just keep adding additional capabilities and modules and ways of doing things that you know, that you could use with the system. So that's basically where I wanted to stop for tonight. Any questions on this? Does this make sense to you? What did you take? The course that a bunch of you took last semester was what? Operational research? Operations research, is that what it is? No. What was it? System dynamics. So you used a package that's somewhat similar to this?
I don't know. I would.
Oh, you weren't in it.
I know that's what they were in, because I was like the only one who wasn't.
Okay. Sort of like this?
Yeah, it was.
Yeah. So you looked at the same kind of, because it seems like the learning curve with this class, and actually last semester as well, and they had done the same thing. They had taken that same course. It seems like they're you're quite a bit further up the learning curve than others. So, okay. So what I'd like you to do, and I'm going to sort of give some broad parameters to this, is model a fast food restaurant. So you've got a couple different steps in a fast food restaurant. You've got first the person who takes your order. You've got the person in the kitchen area that prepares your food, and then you've got somebody who delivers the food to you, right? Either at a drive-in window, or they call your name. If you go to Chick-fil-A, they call your name and they walk over and hand you the bag. Okay, so you got 3 different sort of processes to get through the system. One of the critical things with fast food is the maximum wait time, right? You don't want to sit there. You sit there more than 10 minutes and you're unhappy, right? You sit there for 45 minutes, you've probably already got back in the car and left. So that's a critical parameter for that type of a process. As opposed to something like this where we really don't care that much about a wait time or a maximum wait time at a given queue, long as I've got room to store the parts, and long as my processing time through the system is probably my more important thing. With a fast food, processing time in and of itself is probably less important than that wait time aspect. So I'm not a fast food manager or anything, but just from being a consumer, I would think that's probably the case. So set it up with, and you're going to have a couple decide modules. You're going to have, so you've got a person takes your order, same person takes your money, and they either take your money or they take your credit card, right? So you've got 2 different paths there, and then you've got, and I'm just sort of throwing things out there. Try to include at least some of these things in your simulation. You've got a person who's cooking hamburgers, maybe another resource cooking chicken. Maybe you've got a path, I ordered a hamburger versus I ordered chicken nuggets. I add fries to that. Put some of those kind of loops in there, and then look at things like, what if I have a shared resource in the kitchen? What does that do to my ability to flex my resource and essentially increase instantaneously my capacity? You're on the baseball team. I assume you go by bus. Do you ever pull into a fast food restaurant?
Yeah.
And the person in the fast food restaurant is like, oh my God,
Yeah.
right? You know, you got hungry looking people getting off of a bus. Well, they need to manage that somehow. I'm not really sure how they do, to be honest. I've never worked in a McDonald's, but
Well, there's this one McDonald's down in South Carolina that I think manages it the best. What they do is they take our order and they just write our order on the bag.
oh really?
Yeah. They just list the bag.
Yeah. And they get it right most of the time.
Yeah. Otherwise, they'll just put it all on the tray, which is all fine.
Right. The seniors get the good stuff, and the freshmen get the get the leftovers, right? So look at that and spend some time, you know, trying to, again, what I want you to come out of this course with is a tool you can use when you get into industry, right? So play around with some of the distributions and see how it affects your model. You know, anybody can set this up. Like I've got this set up where it's going to run. It's not going to crash, you know, just based on my times. You know, I have parts come in slower than I can process them. So I've got it set so that I build little bitty queues, but not ever huge ones, you know. But that's not reality. Sometimes you're going to get, you know, a system perturbation where, you know, it all hit the wall at the same time, and how do you recover from that? How quickly can you recover from that? So you can look at, and maybe this is beyond this exercise, but you can also look at things like if a queue reaches a certain level, then you can add a resource. And that's typically probably what you would do. You would reassign a resource. Whoever's taking the garbage out or whatever is likely to get put on the line to make food or service customers, or if things really get crazy. So that's the assignment. I'd appreciate it if you could get it to me by, say, noon time on Wednesday, a week from today, or sooner. I'll look, if you want me to look at something specifically, you get stuck on something, email it to me. Email me the model. I'll look at it and get back to you. But if otherwise, just get it to me before noon or by noon on Wednesday, and that's for everybody in the class as well as people online. Okay, so I think I'm pretty satisfied with what you're doing so far. Again, I'm not big on tests. If we can do this by doing presentations and talking through your simulation, I get a better sense of whether you know this stuff, you know, in a practical sense to be able to use it than if I try to construct a test. So if we can do this basically every week where you make do a model, do a presentation kind of thing, I think that's probably best for this type of course. So I think we're doing good so far. All right, I'll see you next Wednesday.